All right, here's 6.7, modeling with exponential and quadratic functions. All right, first degree equations are going to have something called a common first difference. Okay. And second degree equations will have a common second difference, and I'll explain what that means in just a second. So, looking at this XY table, I want to see, do these XY pairs fit a first degree equation, which would be linear, that would be a straight line, right? And a second degree equation would be a parabola. So maybe it fits one of those two types. It could be something else. But there's a nice little test we can do to check, and that's by looking at the differences. Okay, so you need, in order to do this test, you have to have the x's be evenly spaced. It doesn't have to start with 1. I could start with a negative number or any number. And it doesn't have to count by ones, but it has to be consistent. So, you know, if it was counting by 3s or 4s or 5s, that's fine, but you want these spaces to be the same from x to x. And if that's true, if those spaces are consistent, then you can look, well, how are we getting from y coordinate to y coordinate? So you want to think, what are you adding or subtracting? And here we're adding 3 to get from 4 to 7, and we're adding 3 all the way down the line. So this has a common first difference. And that means I know that a first degree equation, which is linear equation, would fit this data. Okay. All right, so looking, then part B says write an equation to fit the data using the linear regression function on your calculator. So I'm going to use you could write an equation for this line by using two of the xy pairs, because we could find the slope then with the two xy pairs, right? And then we could, once we have the slope, we can find the y-intercept from that, or you could do point slope form. But I'm going to do a regression on my calculator because that's what I'm going to be using for the more complicated equations, second or third or fourth degree even. And we can do logarithmic functions and exponential ones as well. Okay, so, all right, what I'm going to do is input this XY table into my calculator. I'm using a TI-84, but it'll be basically the same on any TI graphing calculator. Okay, so I'm going to hit the Stat button, which is near the top middle there, and then I'm going to choose Edit. And the first thing in the edit column is edit. That's what I'm going to choose to input my XY table. I already have an XY table in here, so this would be the X's and the Y's. So we want to put this in list 1 and list 2. You could write right on top of this. Actually, my X's are what I already have here, but the Y's are different. Okay, I could write right on top of them. I can also use the delete button if I want to delete a certain a certain value, but I can also go up to the top and highlight L2 and hit clear and then enter, and then it'll clear out all of those Y's. So if you ever need to clear all the X's or all the Y's, that's a quick way to do it. Okay. Okay, so I'm going to hit 4 for my first Y, and nothing shows up in the chart, but I have to hit enter, then it's in there, and then I'll do the same thing with 7, 10, 13, and 16. There are no negative values in this XY table, but if you do have one, you want to use this negative button, the one in parentheses, not the minus, because we're not subtracting anything where we would be saying negative whatever. Okay. All right, so I've got those. I've done this part. I've inputted the XY table. Okay. So now I'm going to go back to the Stat menu, and I want to do something with my XY table. I'm going to go over the Calc column, and I want to do a regression. Okay. So you see these ones here. We've got a linear regression, quadratic, cubic. So if I had a second degree or third degree or fourth degree equation, I could do one of these, but I've got a linear equation, so I want to use this one. There's another form down there, but I always use this because it's going to be in y equals mx plus b form. Okay, so I'm going to choose that first linear regression. Okay, you might have a screen like this, you might not. If you have this screen, just make sure you're using the right lists, like your X list that was my L1 list and so forth. You can basically usually just hit enter until it gets past this screen, and then you should hopefully get to a screen that looks like this. So, oh, I forgot to write on my notes here. I used the linear regression button function, because I knew it was a linear function, okay? And this is telling me, okay, in the form y equals ax plus b, they call it y equals ax plus b rather than y equals mx plus b. Then they tell me what the a and the b are. So this is going to be y equals 3x plus 1, okay? And you could test this out. Any of these xy pairs should satisfy this equation. Like 3 times 1 plus 1 would give me 4, right? 2 times 3 plus 7, sorry, 2 times 3 plus 1 gives me 7, and so forth, right? Works with all the xy pairs. Okay. All right. So let's try another. Looking at this one, I see my x's are evenly spaced, so that's good. Okay. Now, I'm not really adding to get from term to term, at least to begin with. I'd be subtracting, but you could think of that as adding a -3, right? I'm just going to put -3. I'm subtracting 3. Then I'd be adding 1. Then I'd be adding 5. And then adding 9. So hey, those first differences aren't, it doesn't have a common first difference, so it's not first degree. But what we can do then is look at the second differences. So the second differences are the differences of the first differences. So I'm going to look, well, how am I getting from difference to difference here? How am I getting from number to number here? And so here I'd be adding 4 to get from -3 to 1. You can always take a number and subtract the previous number. 1 minus -3 would give me 4, right? That's another way you can figure it out. Not that you need that with numbers this small, but 1 plus something equals 5. That would be 4. 5 plus something equals 9. And hey, I've got the same value here, okay? You could extend this. The third, if it has a common third difference, then it's going to be third degree, but I've already figured out this one's going to be second degree because it has a common second difference. Okay, so that means this is going to be quadratic. So a parabola would fit this xy table, okay? You could take a couple of the points. I think you need 3 of the points and make a system of equations and then solve that by hand that way. So that's another way to... So, you know, if we're writing an equation in the form y equals ax squared plus bx plus c, you can figure out what the a, b, and c are by using 3 of these xy pairs and plugging them in, making a system, but that would take a while. It's pretty quick to do this with a calculator like this. Okay, so I'm going to hit stat, edit again, and I'm going to put in this new xy table. Again, make sure you use that negative right there when you type in -2. I'm just writing right on top of my other values here. Every time I hit enter, the cursor just moves over, so I can do this with one hand. Okay, and then for my y's, I've got 6, 3, 4, 9, and 18. Okay, so I got that in there. I'm going to go stat and then over the calc column. And the only difference here is I'm going to choose quadratic regression instead of linear regression because this is a quadratic function here. Okay, so stat menu over to calc. And I'll go down to quadratic regression right there and kind of just hit enter until you get past that screen. And then we've got this. So it's giving me that A, B, and C in this format. So in the format y equals ax squared plus bx plus c, it told me A is 2, B is 3, and C is 4. Okay. You can do these quadratic ones by hand again, and that's in chapter 1. I've got a video that explains how to do that by hand, but I'm just using regressions because we're going to have to use regressions on, especially on the logarithmic functions that we're getting to soon. Okay, on the next page, exponential functions are going to have a common ratio. Okay, so my pen's down there. I need a new pen. All right, so if you my x's are evenly spaced, that's good. If you look at the y's, if you look at the differences, it's not going to have a common first difference. It's not going to have a common second or third or fourth difference either. Okay, because this is actually going to be an exponential function that fits this. So instead of a common difference, if you're having trouble finding a common difference, you can check to see if you've got a common ratio. And the ratio is whatever we'd be multiplying by to get from term to term. Okay, so let's think about this. I need to figure out 192 times something. Well, let's say we're multiplying by r, okay? And we want to figure out what r equals. R for ratio. Well, I can write a little equation here. 192 times r would equal 768. Okay, and then I just need to divide by 192. And let's see. 768 divided by 192 is 4. Comes out to exactly 4. So now that I figured out that this is 4, that I'm multiplying by 4, I want to test to make sure that ratio works with the rest of these. That's really going to get me from y value to y value. Okay, so 768 times 4. Hey, that does give me 3072. Let's multiply that by 4. 12288, 12,288, and the last number there, 49,152. Okay, so that's the common ratio, and you don't necessarily need to write a little equation like this every time. Just as a little shortcut to find a ratio, just take any y value and divide it by the previous y value, because that's really what we end up doing here, right? We took 768 divided by 192, and that gives me the 4. Or I could take 49,152 divided by 12,288, that would give me the 4. Okay, so now I know, since this has a common ratio, then it's going to fit an exponential function. So the answer here is exponential. Okay, all right, so we're going to do the same kind of thing. We're going to do a regression. Okay, so I'm going to go to the stat menu again, and I'll choose edit, and I'm going to input. Here, I'll clear out these lists. I'm just highlighting L1, clear, enter, highlighting L2, clear, and enter. Okay, so let's put in this XY table. 3, 4, 5, 6, 7 are my X's, and then 192, 768. Okay, I've got my my XY table in there. And now we're going to go to Stat and Calc again to do a regression. I'm looking for an exponential one. So if you scroll down a little bit here, I had to go, it's at the 10th spot, so I had to scroll down all the way down to the bottom of the list there, and I got an exponential regression. That's what I'm going to choose when it's an exponential function. Okay, so let's try that out, and I hit enter a couple times to get past the screen. And there I've got, it's telling me, okay, we're going to use the format a times b to the x, and then they tell me what a and b are. So a is 3, and 4 is b. So you could use the little dot for multiplication, however you want to write that. But what you don't want to do is take this and simplify this. This does not equal 12 to the x. That is incorrect, right? Because it's 3 to the first times 4 to the x, so you can't combine those. You can't simplify that any further. Okay. All right, and then we're going to take this a step further. We're going to use this model to predict to find. Okay. Let's use this model to find y when x equals 11. I'll fix that typo. Okay, so we've got this this function here, and I just need to plug in plug in 11 for x. I've got the 4 right there already. So then I'm going to use my calculator to simplify that. So let's see, 4 to the 11th. I want to do that first, right? Don't do the exponent before the multiplication, and then multiply by 3, and then y is going to equal this large number. Okay, so I got 12,582,912. It's a large number because those y's are going up exponentially. They're getting large really quickly. Okay. All right, let's take a look at another. So what type of equation fits the data? So I'd be looking, first off, maybe you'd look at the differences. I can see those y's are increasing really quickly, just like these are. So I'm thinking that this might be an exponential function and not a first or second or third degree function. So I'm going to try exponential first. I'm going to see if this has a common ratio. Okay, and to do that, I'm going to take any number. Remember, trying to see what r would be here. So 21 times r equals 189, and that means r would equal 189 over 21. You could take any y value and divide by the previous y value. So let's see, 189 divided by 21, and I've got 9. So I'm multiplying by 9 here. Let's see if the rest of these I'm multiplying by 9. So 189 times 9, that does give me 1701, and I'm just testing it down the line here. Yeah, it gives me those y values if I multiply by 9 every time. So I do have a common ratio. That means this is exponential again. Got to figure that out because we need to know what type of regression to do on our calculator. Okay, I can see I've got the same typo down here because clearly I did some copying and pasting. Okay, so let's write an equation. Okay, so same kind of deal. We're going to the Stat menu, and we're going to go to Edit to input our list here. I'm just going to clear out those lists, highlight L1 and L2, clear and enter. Okay, so now I got a blank slate, and you can see the y's here. We're not counting by ones, but they're still evenly spaced, right? 1, 3, 5, 7, 9. We're counting by twos instead. Okay, and then y's. Okay, and now I'm going to go to Stat and go over to Calc. And I know this is exponential, so I'm scrolling down until I get to that. Hit enter a couple times, and then I can see this is going to be y equals 7 times 3 to the x. Okay, and again, you can't simplify that any further. That's not the same as 21 to the x. All right, and now this says find x when y is 11,160,261. Okay, so we're plugging in the y value into this equation now. So let's go ahead and do that. Okay, so I'm trying to solve for x. Let's start by dividing by 7. You can divide the whole equation by 7. Okay, and still got a large number over here, not quite as large anymore. Still over 1 million. So that's what 3 to the x equals. Okay, now the only way I can isolate x is to put this in log form. I'm going to have to use a log, right? Doing the square root's just going to put 3 to the x in a square root. That's not going to help me. Dividing by 3 is not going to work either. That's not going to get rid of that 3. So I'm going to want to put this in log form. I'm going to have to write a little smaller here. So my base is going to be 3. The large number is going to be the argument or the contents of the log. And then the exponent gets isolated, okay? And when I put that in my calculator, I'm going to have to use change of base. So I'm going to do log of the large number over log of 3. Okay, close the parentheses there, and then I'm going to divide by log of 3. Now it's in base 10. Now you can put in any base you want, but this is the one that's programmed in your calculator. And then this comes out to 13. Okay, and you could test it out. 3 raised to the 13th should equal this number, right? Let's just do a quick test. Yeah, I can see that works there, right? That x value works. And it would work in the original one if I multiply that by 7. That'll give me that 11 million number. Okay. All right, let's look at some logarithmic regressions on the next page. When you go to the Stat menu and over to Calc, and you scroll down for a while, there is something called logistic, but I like to use the ln reg, which means that's going to be a natural log. The natural log button is ln, right? And that's what we write ln for a natural log. So it's going to look a little strange as when you do the logistic regression. It's not actually going to look like a logarithmic equation. So yeah, I'm actually going to use a natural log regression. Okay. So yeah, I'm going to be using ln reg. Okay, these ones, there's no good test that we can do, at least with the tools we have at our disposal at this point. Looking at an XY table, there's no good way to tell that that's going to be logarithmic. But this problem just tells us a logarithmic function closely models the data. So that tells me, okay, I'm going to do a log regression. So I'm going to do a natural log regression, okay? So let's input this data table. 1, 2, 3, 4, 5, 6 for my x's. And, okay, I'll put the rest in here. Okay, just double checking for typos. I think I'm good there. Okay, once you get it in, you can go back to the stat menu and go over to calc. And now we're going to choose, it's easy to choose a linear regression on accident because it's just one letter difference, right? But we want the LN reg, this one. We want a natural log regression. Okay, so I'm going to get past that screen. And then it's telling me the format is going to be oh, I guess I should write it down here. So, yeah, I didn't really need to put this again here, but this is what I'm using here. So my format is A plus B and then natural log of x, okay? And it does say round A and B to the nearest integer on this one. Those A and B are really close to integers, okay? So A is going to be 7, and then 8 times natural log of x. You could write the plus 7 at the end. The calculator put it in this format, I think, so that you could tell that if you had a plus 7, you could tell the plus 7 isn't inside the log. Now it's really clear it's not inside the log, okay? So if you did put it at the end, I would put parentheses around the x and then plus 7, all right? All right, so it says that it closely fits this, so I got those decimals, but it's going to really closely fit this as well, okay, since that's just barely rounded from those decimals, okay? So I'm going to use the model to find y when x equals 22. So all I have to do here then is use this equation and plug in 22, okay? So I'm going to find 8 times natural log of 22 on my calculator. So I'm typing 8, and then there's the natural log button right below the log button, okay? 8 times natural log of 22. I'll hit enter, and then I'm going to add 7 to that, and I've got about 31.73, I'll call that. Okay. All right, let's try another. Okay. Telling us again, hey, we're going to use a log regression, so I'm going to natural log regression. Let's input this data table. Stat, edit. I got the same x's, so I'll just leave those be, but I'll clear out my y's. If you accidentally use the minus key instead of the negative key, you will get an error when you try to do the regression, okay? All right, so got that in there. Let's go to stat and then calc, and I'm going to go down to that linear regression. Get past the screen. This goes pretty quick once you get used to it. And then it's asking us to round to the nearest integer again. So I'm going to have y. I should have really put that on the last problem. It's about equal to 7 plus 8 natural log of x. So this one's about equal to negative 3 plus 5 natural log of x. And then we can use that now to make our prediction, okay, on part B. So let's plug in. Now we have the y value here. So 21.02 is about equal to negative 3 plus 5 natural log of x. Okay, I'm using about because these numbers are rounded, the negative 3 and the 5, right? So I'm trying to solve for x. So let's first add 3 to both sides. So now I'll have 24.02 is about equal to 5 times natural log of x. Okay, and now I can divide by 5. 24.02 divided by 5 is 4.804. And seems like this always happens, but I'm running out of space. I'm going to have to go over this way. All right? So now to get the x out of the log, I have to convert this, right? So you have to know, you don't have to write this necessarily, but you have to know that natural log is log base e of x is about 4.804. And so to convert this, my base is e. The 4.804 will be the exponent in exponential form. And then the x gets isolated. Now I've got something I can put in my calculator, so I'm going to use this this button right here, which is a little hard to see, but I'm using I'm going to hit second ln to get e to the x. There's also an e key like above the division, so you could use that and then raise it to the decimal. But I'm going to use this button. So I've got e raised to the 4.804, and now I've got 121.997. I'm just going to round that to 122. It's pretty close to 122. Okay, and there's my x value. All right, and that is the end of the lesson, and I'll see you next time.